Hello, my esteemed viewers. This is Medical Science Lecture Room. Today, I'll be taking you through a topic known as Remainder Theorem. This is an aspect of what your polynomial. Remember, I have done videos on polynomial, the degree of polynomial, addition, subtraction, multiplication, and division of polynomial. But today, we'll be looking at Remainder Theorem. So let's quickly state the Remainder Theorem. The Remainder Theorem states that if a polynomial f of x is divided by x minus a, the remainder will be equal to f of what? A. I take that again. The remainder theorem states that if a polynomial f of x is divided by x minus a, the remainder will be equal to f of a. What this means is, supposing I have a polynomial f of x and is divided by x minus a, we've been told, according to Remainder's theory, instead of using the long division method of polynomial to divide that expression such that you finally get the remainder, you will simply say that the remainder of this expression, when you divide f of x all over x minus a, the remainder will be equal to what? F of what? A. How do we arrive at what? F of A. What this means is that if you say the divisor, if you take the divisor equal to 0. Now this is the divisor x minus A and equate it to 0. And I make x the subject of the formula. It becomes what? X equal to what? A. If you substitute A in this expression, that will now give you f of x. Remember, initially it is f of x, a numerator. So in place of what? X, you're going to have what? F of what? A. That's what is equal to what? The remainder. That's equal to the remainder. What this is simply telling us, instead of dividing using the long division method to divide, all you need to do is just say the divisor equal to 0, whatever that is given to you. Any expression given to you, and you're asked to find the remainder of that expression. If it is a subjective exam, but if it's an essay exam, then you need to use the long division method to show that. But if it's a subjective exam, it's best for you to use this method. How do you arrive at that? Simply say that the divisor is equal to 0. If the divisor is equal to 0, make the variable the subject formula. In this case, my divisor is x minus a. I have said x minus a equal to 0. I now make x the subject of the formula. If you have done so, it becomes x equal to a. Because x is equal to a, what you then do is to substitute this a. This a, substitute it in the expression f of x. Remember that f of x in this case is your dividend. I told you before that the numerator will be called the dividend, while the denominator is called what? The divisor. So what you do is, when you say divisor equal to 0, and you make the variable, the letter there, the subject of the formula, the x, the subject of the formula of the x of the divisor, make it the subject of the formula. Once you do that, in this case, we're going to be having x equal to a. And when you get x equal to a, then the a here should be substituted in what? The dividend. And that is the same thing as what? F of a. And they said that will become what? The remainder. As simple as that. Instead of having to use the long division method, and then you say this is the divisor and this is what? F of x, which is the dividend, and then you use that method to get, that will be lengthy. That will take you a long time. But if it's an essay exam, you must do this. If it's an objective exam, you're going to take this applied remainder theorem. Now let's see how we can apply that. Now supposing I have a polynomial, for instance, supposing we say given f of x equal to x raised to power 3 plus 2x raised to power 2 minus x minus, let's say, 5x. Find the remainder. Find the remainder when f of x is divided by x minus 2. Now, this is a question that we have before us. The question is, given that f of x is equal to x cubed plus 2x squared minus 5x. Now, the question is, find the remainder when f of x is divided by x minus 2. This is simply x cubed plus 2x squared minus 5x all over what? X minus 2. We've been asked to find the remainder. Remember, this question do not require us to find a quotient. If the examiner said find the quotient, then we must use the long division method to divide this. And at the end, we're going to have our quotient here. You know that if you use the long division method, this will be what? The position of your divisor. This will be the position of your dividend. By the time you finish dividing, you're going to have the quotient up here, and then the remainder will be somewhere here. If that is not understood, you look for my video on division of polynomial. You will get it clearer. Now, but in this case, because the examiner is not interested in the quotient, we are not interested in the quotient. We are only interested in what? The remainder. And because this is an objective exam, perhaps, then we have to apply Remainder's theory. But if it's an essay exam, even if it is only remainder that is requested, we will still use the long division method, because we'll be expected to show every step that we have taken. But for an objective exams, you do not need all of that. All you want is the remainder. Therefore, apply the Remainder's theorem. And how do I go about it here? I will now say solution. I said equate your divisor to what? Equate it to 0. Let my divisor be equal to 0. Therefore, x minus 2 will be equal to 0. I will make the x the subject of the formula. This becomes x equal to 2, where minus 2 crosses equality sign to the other side of the equation. You know that that will become x equal to 2. And so if x is equal to 2, I will now say, I will look, the remainder is equal to f of 2. What this means is that this 2 should be substituted in what? F of x. Remember, the f of x is this. And so if I have gotten x equal to 2, what this means therefore is that I should substitute anywhere I have x, I should substitute 2. Therefore, this will be equal to, in place of what this x, remember we are substituting in this expression that was given to us, and this of course is the dividend. So I will substitute here. If I am doing that, it becomes 2. Because this x is raised to power 3, this 2 should be raised to power 3. Plus, that's the plus sign. Then we have 2 here, that's the 2, and the next is x. This x has to be what? 2 raised to power 2. Remember, anywhere we have x, we will substitute 2 there. And so for this x, there is 2, we've substituted. And because this x is raised to power 3, therefore this 2 has to be raised to power 3. Now the next is plus. That's the plus sign, we have retained it. Then the next is 2. That is the 2. In place of this x, we have to substitute with 2. That's the 2 you have seen here. And then because this x is raised to power 2, therefore this 2 should be raised to power 2. Next is what? Minus 5. And because 5 here is multiplying x, this minus 5 has to multiply what? 2. And then you solve this to the end, and this will be equal to, of course you know, 2 raised to power 3 is 8. Then this is plus, of course here again, 2 raised to power 2 is 4. 4 times this will give us 8. Then this times this will be minus 10. This will be 8 plus 8, of course, 16. 16 minus 10, that, of course, will be what? 6. Hence, the remainder is equal to what? 6. Now, if we were to use the long division method to divide this, the final answer would definitely be what? 6. Let's see. So, using the Remainder's theorem, we've gotten the answer to be what? 6. The examiner or the question required or requested us to find the remainder when this is divided by x plus 2, and the answer is 6. We've seen it using the Remainder's theorem. And so we want to confirm this. We want to see if we divide this using the long division method, if we're going to have the same 6. Though that wasn't the request of that question. By right, we're supposed to stop here using the Remainder's theory. But in case you have an essay exam, what do? You need to show how you arrive at this 6. It will not be by Remainder's theorem. For that reason, I want to use the long division method to see if we will arrive at that same 6. And to do that, you have to draw this. Draw this sign. Where here will become your divisor, and this will become the dividend. And now I have to divide. But how do I go about the division? I will ask myself, what is the highest power of this? Or what is the degree of the dividend? The degree simply refers to the greatest power. You watch, you see that this x has to power 3. This x has the power 2. This x has power 1. You agree with me that the highest power is what? 3. And it comes from this x. when you look at the divisor has this and this. What is the highest power of the variable, the highest power of the letter? Of course you know it is 1, because this is 1. Why this x can be placed here, and if you bring in x here, this will be raised to power 0, and so it therefore means that the highest power of the divisor is simply 1, because this x has power 1. Why this x has power 0? So it therefore means that the degree of the divisor is 1. It is 1 because of what the first term here. It is 3 for this one. It is 3 because of what this term. For that reason, I'll be using this to divide this. I will now say x into x cubed. What that means is x cubed divided by what? X. And of course, if you work that will be x squared. Immediately you say x squared. That x squared should be written up here. And having written the x squared up there, I have to use this x squared to multiply the divisor. And then this becomes x squared times x. That, of course, will be x cubed. X squared times this will be what? Minus 2x squared. And then I will draw this line. Now, at this point, I will now subtract. Why am I subtracting? Because I want to ensure that this x cubed disappears or is eliminated, or it turns to 0. And so I'll bring in a minus sign. I know if I bring a plus sign, the plus sign will not lead to what? The elimination of what? X cubed. So I need a minus sign instead. Therefore, it becomes x cubed minus x cubed. That, of course, is 0. I will now say 2x squared minus 2x squared. Remember that this is x squared, this is x squared. That means like terms. And because they are like terms, I will say 2x squared, which is this one, minus, which is this minus, which is this one, 2x squared. Of course, this will become 2x squared plus 2x squared. This will give us 4x squared. That 4x squared, that will give us 4x squared. And so that 4x squared is written here, 4x squared. And minus 5x minus 0. Why are we saying 0 here? Because on this line, there is no x. If I'm to bring in x, it becomes plus 0 what? X. It becomes therefore that minus 5x minus 0. That will give us minus 5x. Now at this point again, this should have been our remainder, but it cannot be, because this is still greater than this one. How is it greater? Because the highest power here is 2, while the highest power here is 1. Therefore, we'll continue to divide. You can only stop to divide if the power here is less than the power at the divisor. And so for this reason, we'll continue to divide. I will therefore say x into 4x squared. That means 4x squared all over what? X. When you divide, this will give us plus 4 what? X. I will again say, having written 4x here, I will say 4x times this. That again will give us 4x squared. 4x times this, that will give us minus what? 8x. I will draw this line. Once you draw that line, the next thing you're going to do is to bring in a plus sign or a minus sign, depending on what the one that will eliminate these first terms. So I will go for what? A minus sign. As I bring in a minus sign, this becomes 4x squared minus 4x squared. That will turn to 0. That's beautiful, because we want x squared to turn to 0. The next is what? The next one is minus 5x. This is the minus 5x minus, which is this minus, which is this minus 8x. I will ask, this will be minus 5x. This times this will be plus 8x. Of course, you know that minus 5x plus 8x will give us what? 3x. I will now come here and write there 3x. What do you see? The power of this x is 1. The power of this x is 1. I will continue to divide. I will now say x into this. In other words, 3x all over what? X. This 3x divided by this x. This will cancel this. I will have here plus 3. Plus 3 times this will give us 3x. Plus 3 times this will give us minus 6. I will draw this line as usual. What am I supposed to do again? I'll bring in a minus sign. It has always been a minus sign, because the minus sign will actually lead to the elimination of this 3x. And so this becomes 3x minus 3x. That becomes what? 0. Remember, here we have what? Minus 6. On this line, there is no number there. And so what do? I can possibly come here and attach 0 there. Where 0 would, bringing 0 here will not change 3x from what it was. It was 3x. not 3x plus 0. But it still doesn't change. Even when you say 3x plus 0, it is the same as what 3x. I'm bringing there 0 to enable you know that we're going to say 0 minus 6. And that, of course, will give us what? Plus 6. You can see that same 6 that we got when we use Reminder's theorem is the same 6 we are seeing when we do what? Use the long division method to divide that. But you know, in subjective exam, it's going to take you a long time to go through all this onto this point. So it appears to be shorter when you apply Reminder's theorem because the examiner is not interested in the quotient. Remember, when you use this method, you get also the remainder in addition. You get the quotient. But if you use Reminder's theorem, you will not get the quotient. You only have what? The remainder. I want to believe you have understanding of how to apply the Reminder's theorem, the Reminder's theorem as well as its application. In case you have any question, in case you have any comment, please go to the comment section, drop them there. Again, subscribe to this channel, turn on your notification bell, like the video, and share it. Thank you.